This is part 2 of the linear regression scatter plots, association, and causation video. So I wanted to talk a little bit more about what this equation means right here. So we know our slope is our rate of change. That's our m. So what is it saying? Our x values are the weight and our y values are our time. So this is saying for every extra pound on the weight of the dog, it's going to take them almost a second extra to complete this course. So it's going to take them 0.82 seconds more per pound, or 0.83, I guess, if you're rounding. But I mean, close to a second for every pound that the dog weighs. So for every time you go up in a pound, it's going to add almost a second on. What about this y-intercept? This kind of doesn't really have a meaning that really makes sense here, because we know our x is pounds. So this is saying if you don't weigh anything at all, it's still going to take you 16 seconds to complete the course. So in this case, really doesn't have a meaning that actually makes sense. But for a 0-pound dog, it would take pretty much 5 seconds to complete the course. So is that true? That doesn't really make any sense. But I mean, theoretically, that's what it means. Okay, I want to show you one more thing in the calculator, because you know how we got this scatter plot and this line? I can actually have the calculator do that part for me. So if I go back to my current document and I go to Document, Insert, Data and Statistics, it's going to make me a nice little scatter plot here. So if I go down here and click, we said that weight was our x value and time was our y value, and that's pretty much the same exact thing that I had graphed. Going to go to Menu, Analyze, Regression, and pick that Show Linear mx plus b. And there's the exact equation that I got. And pretty much it looks exactly like it did when I drew that line in. I mean, they had it actually a little bit higher going through that first point. So I don't even know if I can move it from here. Yeah, I can. Okay, so they had it more looking like that. Okay, this is talking a little bit more about this correlation coefficient, which I kind of drew some pictures already of this one. So which one's the strongest? This is the strongest. This is the second strongest, even though it's negative. This is the third strongest. This one is barely going to even look like a correlation. A correlation of 0 is just going to be like no correlation. Like you can't even put a line in here, because is it going up? Is it going down? I don't even know. So weak negative would be this one, negative 0.47. I mean, it's not even half. It's below half, and it's negative. So that's not going to look very strong. It's going to be like you can barely tell that these dots are decreasing from left to right. A weak positive, I mean, this is really weak, 0.23. Strong positive is going to be this 0.86. And strong negative is the negative 0.79. And I would argue not that strong. A 0.79 is not super strong. I mean, definitely the 0.86 is stronger. Okay, last part. Association and causation. So association is that you can show that one variable and another variable have either a positive thing going on or a negative thing going on. that as one thing increases, another thing increases, or as one thing increases, the other thing decreases. But a causation, truly one variable causes the other one. So Jennifer noticed she sold more snow cones on the weekends than on weekdays. Is that a true cause? Dan observed that more miles he drove, the more gas he used. Well, it's not that it was a weekend like that made it more snow cones. It was just more people were off. So it's not like, ooh, Saturdays are the best snow cone days. Just more people were out and about in the community. This is just an association. There might be other reasons. I mean, what if it was raining all week and then it was really nice on the weekends? I mean, nobody really goes for a snow cone when it's raining. We can't really prove it. This one we can prove. When you drive, you use gas. I mean, that is a causation. We know one variable definitely causes the other variable to go down. More miles, more gas used. Less time he exercised, the more he weighed. Again, that's a causation. We know that there is a link. Scientists have proved it, that if you're sedentary, if you sit on the couch, you're not burning calories. During a particular season, a football team won more games if they played on Friday than Saturday. I mean, again, that's just association. Can we prove that that's true? There could be so many different reasons why a Friday night game, they won more than a Saturday night game. We couldn't pinpoint an exact reason and really prove that scientifically.